Greetings to Dr. Aisha and everyone. My name is Chelsea Julie, and in this video we will be presenting our group project called Application of Derivatives and Integration in GeoScience using Malaysian Case Study. We are from Group 11, and let me introduce you to our group members. There is Muhammad Nur Ehsan, myself Chelsea Julie, Muhammad Faris Nawal, Nurul Iza Batrisha, and Putra Haris. First of all, GeoScience focuses on understanding natural processes of the Earth, such as seismic activity, landslide, or rainfall. Mathematics, especially calculus, plays an important role in analyzing these processes. In this project, we apply derivatives and integration to real case study in Malaysia to show how mathematical concepts are used in real-world geoscience problems. This is the case study that we choose. For derivative, it is a seismic stability analysis for Earth structure in Peninsula and slope stability analysis of the 2021 Hulu Klang landslide. Next, for integration, we chose estimating total rainfall infiltration in Hulu Langat Selangor and monsoon rain events in the Pasir Mas area, Kelantan.
Hi, Assalamualaikum. My name is Nurul Iza Batrisha with Muhammad Azman. Today, I would like to present my case study entitled Seismic Wave Analysis for Earth Structure Investigation using Derivative. Seismic waves are energy waves generated by earthquakes that travel through the Earth's interior. These waves move at different velocities depending on the physical properties of the subsurface material. In geoscience, change in seismic wave velocity help us identify different layers within the Earth's structure. Therefore, analyzing seismic wave travel time is important for understanding subsurface conditions. For this case study, the travel time of seismic wave is represented by T of S, where T of X is the travel time in seconds and S is the distance in meters. Derivatives are used in this analysis because they represent the rate of change of travel time with respect to distance, which allows us to determine the instantaneous seismic wave velocity. To find the seismic wave velocity, the derivative of the travel time function with respect to distance is calculated. Since velocity is defined as distance over time, the seismic velocity is obtained by taking the reciprocal of the derivative of T of x. At a distance of 200 meters, the calculated seismic wave velocity is approximately 1111.11 meter per second. For the conclusion, the derivative calculation shows that the seismic wave velocity increases with distance, indicating change in subsurface material properties. The result obtained from my manual calculation is the same as the result verified using ChatGPT with no difference between both values. This confirms that the mathematical approach used in this case study is correct overall. This analysis demonstrates that derivatives are an effective tool in geoscience for interpreting seismic wave data and understanding the Earth's subsurface structure.
For this second case study, I will explain how derivatives are used to analyze slope stability based on 2021 Hulu Klang landslide. The negative value of the derivative FOST smaller than 0 indicates that the factor of safety decreases continuously as rainfall time increases. From a geoscience perspective, this shows that prolonged rainfall systemically weakens slope stability. From a physical point of view, rainfall alters the balance between the driving force and resisting force acting on the slope, while the weight of the soil increases with time due to continuous rainfall. The shear strength of the soil does not increase at the same rate. The derivative helps us understand this process clearly. It shows that the rate of decrease in slope stability is constant and predictable. This means that the longer the rainfall continues, the faster the slope approaches a critical failure condition. When the factor of safety approach or drop below 1.0, the resisting force are no longer sufficient to counter the driving force, and the slope becomes unstable, making a landslide likely to occur. In the context of Malaysian geoscience and disaster mitigation, this analysis is highly significant. Many landslides in Malaysia occur after several days of continuous rainfall, especially in hilly urban areas such as Hulu Kelang. In conclusion, the value of the derivative that I got from my calculation is negative, which is negative 159.0. It is the same as the answer given by ChatGPT. This case study shows how derivative can be applied in real life to help analyze and reduce landslide hazards.
In this case study, we are examining rainfall infiltration in Hulu Langat, Selangor, an area that frequently experiences heavy rainfall. When rainfall, part of the rainwater infiltrated into the soil, and the infiltration rate gradually decreases as the soil becomes more saturated. To determine the total amount of rainwater that infiltrates into the soil, the method of integration is used. The infiltration rate is given by the function Ft equals 20E minus 0.4T, when the unit is millimeters per hour. Since the function represents a rate, integration is required to obtain the total infiltration over the rainfall duration. In this calculation, the infiltration rate function is integrated from T equals 0 to T equals 2 hours. Mathematically, this integration represents the area under the infiltration rate time curve, while physically it represents the total depth of rainwater that has entered the soil. The result of the integration shows that the total infiltration over the 2 hours period is approximately 27.6 millimeters. From a geoscience perspective, this amount of infiltration contributes to an increase in subsurface water content. However, high infiltration can also increase pore water pressure and reduce soil shear strength, which in turn raises the risk of the landslide, especially after prolonged rainfall. In conclusion, the use of integration allows the total rainfall in infiltration to be calculated accurately. There is no difference between the manual calculation and the result verified using ChatGPT, as all steps and the final value are consistent. Therefore, this result is valid and reliable, and is clearly demonstrates the importance of integration in geoscience application.
Wabarakatuh and good taste and greetings. My name is Muhammad Ahmad Rizwan. In this presentation, I will explain a case study on a monsoon rain event in Pasir Mas, Kelantan, which demonstrates the application of the integration in geoscience, particularly in flood analysis. Pasir Mas is low-lying area located in Kelantan, river basin and highly vulnerable to flooding during the northeast monsoon season. The intense rainfall during this period caused a rapid discharge, which may escape by the river capacity and length to overflow. In this study, the river discharge rate, the modular using the function where QT represents the discharge in cubic meters per second and T represents time in hour after rainfall began. To determine the total volume of water flowing through the river from T equal 0 hour to T equal 10 hours, we apply definite integration. This equation calculates the cumulative water volume over time rather than a flow rate a single moment. By applying integration by part method, the total water volume is found approximately 1,485 cubic meter. Additionally, the ChatGPT generated solution did not explain the calculations that clearly contain severe error. Therefore, students corrected the solution by applying integration method systematically, resulting in clearly and more reliable answer. From this geoscience perspective, this large volume accumulated water, which is short period, indicated high risk river overflow and flooding, especially in flat area like Pasir Mas, with limited draining capacity. In conclusion, this study highlights how integration is important mathematical tool for the estimating total water volume and setting flood risk. The student correctly also emphasized the importance of a verifying mathematical solution when applying calculus to real-world geoscience problems.
We have arrived at the end of our video. In conclusion, this project has shown how derivatives and integration are applied in geoscience through a real Malaysian case study. We learned that derivatives are useful for analyzing rates of change, such as seismic wave velocity and slope stability. Integration, on the other hand, help us calculate total and accumulated quantities, including rainfall and water infiltration. So this application demonstrates that calculus is not only theoretical but also essential in understanding natural hazard and supporting environmental planning in Malaysia. Thank you for watching.